Welcome to Motilal Maths. It is exercise 3.6 of grade 12. MCQ questions. Question number 1. A 0 of x cube plus 64 is first option 0, second option 4, third option 4i, fourth option minus 4. Among the options we can do, see, you just consider first option. This 0 will not make it 0. Positive number will not make it 0. I consider fourth option. See, if x equal to minus 4, x cube plus 64 equal to minus 64 plus 64, it is 0. The fourth option is correct. Hence answer is fourth option, minus 4. Second, if f and g are polynomials of degrees m and n respectively, and if h of x equal to f composite g of x, then the degree of h is, see, just we can write this h of x equal to, it is f of x into g of x. So degrees of f and g are m and n, so it is m into n. It is there in option 1, m into n. Okay, next, question number 3. A polynomial equation in x of degree n always has n distinct roots, n real roots, n complex roots, at most one roots. N distinct roots means, suppose b square minus 4ac equal to 0, two roots will be the same. At the time, we cannot say that the equation will have distinct roots. So, at that time, listen carefully, all the real roots are complex roots only. All the real roots can be called as complex roots. So here, it will have n complex roots. So, option 3. Okay, next, look at question number 4. If alpha, beta, gamma are the zeros of x cube plus px square plus qx plus r, then sigma 1 by alpha is first option minus q by r, second option minus p by r, third option q by r, fourth option minus q by p. See, first we can find alpha plus beta plus gamma, that is minus p here. Alpha, beta, beta, gamma plus gamma alpha, that is q. Alpha, beta, gamma, that is minus r. Now, sigma 1 by alpha is equal to 1 by alpha plus 1 by beta plus 1 by gamma. Okay. Now, here we can take the LCM. Alpha, beta, gamma plus alpha gamma plus alpha beta. It is equal to, this numerator is q, denominator is minus r, hence it is minus q by r. It is there in option 1. So option 1, minus q by r. Now, going for question number 5. According to the rational root theorem, which number is not possible rational 0 of 4x power 7 plus 2x power 4 minus 10x cube minus 5. So here I consider rational root theorem that given can be taken as p of x, 4x power 7, 2x power 4 minus 10x cube minus 5. Okay, that first one can be treated as a0, an equal to 4, and last coefficient can be taken as a0, it is minus 5. Now, we can find possible factors of p. Before P by Q form to be found. Possible factors of P, it means possible factors of A naught plus or minus, for minus 5 will get divided by 5, minus 5 will get divided by minus 5, so plus or minus 5, both will get divided by plus or minus 1. Next, we can find possible factors of Q. It is AN, 4 was coefficient. So possible factors of 4 is the divisibles. 4 will get divided by 1, 4 will get divided by 2, 4 will get divided by 4. Now next, we can consider P by Q forms. P by Q forms. See here, plus or minus 5 by 1, so plus or minus 5 only will come. Plus or minus 5 by plus or minus 2, so plus or minus 5 by 2. Plus or minus 5 by 4, plus or minus 5 by 4. Plus or minus 1 by 1, plus or minus 1. Plus or minus 1 by 2. Plus or minus 1 by 4. Now, minus 1 is there in first option. In second option, 5 by 4 is there. In fourth option, 5 is there. In third option, 4 by 5 is not there. So, that not possible ratio 0 is 4 by 5 only. It is answer 3, option 3, 4 by 5. Okay. Now, going for sum number 6. The polynomial x cube minus kx square plus 9x has 3 real zeros if and only if k satisfies modulus k less than or equal to 6, k equal to 0, third option modulus k greater than 6, fourth option modulus k greater than or equal to 6. First, that given can be taken as p of x. Let p of x equal to x cube minus kx square plus 9x. Here x can be taken out. X square minus kx plus 9. Since x equal to 0 is a root, remaining x square minus kx plus 9 equal to 0. See, they said 3 real zeros. It means we can take discriminant greater than or equal to 0. Its discriminant is going to be taken as b square minus 4ac greater than or equal to 0, b equal to minus k, so k square will come minus 4, a is 1, c is 9 greater than or equal to 0, which implies k square greater than or equal to 36. You just see minus 6 plus infinity minus infinity. It means you may take any value before minus 6, by chance minus 7. Minus 7 will satisfy this inequality because 49 will come. Minus k, if k replaced by minus 7, then it will be 49. 49 is more than 36, so here it gets satisfied. If you take any number between minus 6 and plus 6, none of the points will satisfy this inequality because by chance you can take 0, put k equal to 0, 0 greater than or equal to 6, 36, it is not correct. So here it won't be satisfied. After 6, you may take any point, it will get satisfied. So it will get satisfied. So what I'm saying you here, that minus infinity less than k less than or equal to minus 6 and plus 6 less than or equal to k less than infinity, then the same can be denoted by modulus of k greater than or equal to 36. If so, and the modulus k greater than or equal to 6. It is there in option D. Fourth option will come. Okay. Now, going for question number 7. The number of real numbers in closed intervals 0, 2 pi satisfying sine power 4x minus 2 sine square x plus 1 equal to 0 is. Okay. See, given it is sine square x minus 1 the whole square equal to 0. Sin square x minus 1 equal to 0. Sin square x equal to 1. Sin x equal to plus or minus 1. Sin x equal to plus 1. Sin x equal to minus 1. See, it will be obtained when pi by 2. It will be obtained when 3 pi by 2, when x equal to 3 pi by 2. So, from 0 to 2 pi, only these two possible numbers are there. Therefore, the total number of roots equal to 2. It is there in option 1. Okay. Next, question number 8. If x cube plus 12x square plus 10ax plus 1999 definitely has a positive 0. If and only if, say, 10a can be taken as p of x cube plus 12x square plus 10ax plus 1999 in p of x, at least one negative sign should be there. At least one negative sign should be there. Then only at least one sign change will be there. If at least one sign change is there, then only there will be a positive root. So this a must be less than 0. It is there in option C. Okay. Now going for question number 9. The polynomial x cube plus 2x plus 3 has 1 negative and 2 imaginary zeros, 1 positive and 2 imaginary zeros, 3 real zeros and no zeros. First, it can be taken as p of x. P of x equal to x cube plus 2x plus 3. Then listen here, there is no sign change. There is no sign change in p of x. Therefore, there is no positive root. P of minus x cube minus 2x plus 3. Only one sign change is there. Number of sign changes equal to 1. Therefore, number of negative roots equal to 1. Now, 0 is not a root. Therefore, real root is 1. Total number of roots is 3. Hence, the polynomial will have one negative root and remaining are imaginary. It will have 2 imaginary roots. It is there in option 1. So option 1 is correct. Okay. Now going for question number 10. See, the number of positive zeros of the polynomial sigma r equal to 0 to n NCR minus 1 power r x power r can be written as NC0 because minus 1 power 0 1 x power 0 1. Next r equal to 1, negative sign will come, NC1 x. Next r equal to 2, it will become positive, NC2 x square minus NC3 x cube. It will go on like this. The last number will be minus 1 power, NCN minus 1 power n x power n. See, it is known as 1 minus x whole to the power n. If it is equated to 0, x equal to 1 will come n times. So, number of positive zeros equal to n, it is there in option 2. That's all, got over.